So this was pop quiz 8, which was related to topic moment, vectors, and the motion. In the first question, like the first three are MCQs, and then there's a structure question. The diagram shows a uniform meter rule or a meter scale, which is pivoted at its midpoint. And W1 and W2 are the two weights which are attached on either side. The rule remain balanced, means it is in equilibrium. So if the object is in equilibrium, what we can say there will be no resultant moment or no resultant turning effect, or the clockwise and anti-clockwise moment will be equal. And we can also say there will be no resultant force. So no resultant moment and no resultant force, these are the conditions for object to be balanced or in equilibrium. So direction of the resultant moment, it will be zero, because there is no resultant moment, so it is zero. And direction of the resultant force, there is no resultant force. There are forces, but the resultant force will be zero. So W1 is causing an anti-clockwise moment, W2 is causing a clockwise moment, they will balance. And same thing, W1 is acting downward, W2 is acting downward. So force from the pivot will act upward, and that will balance with a total downward force. So no resultant moment and no resultant turning effect, or we can say no resultant force or no resultant moment. That is when object is in equilibrium. That's why option D is the right answer. Then which physical quantity is a vector quantity? Mass of a vector means like it should have a magnitude as well as a direction. Mass is not a vector quantity because mass is not having a specific direction. Density is not a vector quantity because it does not have any specific direction. Temperature is not a vector quantity because there is no direction. Velocity is a vector quantity because it is distance travel in 1 second at a particular direction. So if we say 3 meters per second towards east, that shows that the object is moving in a specific direction. That's why D is the right answer. The resultant force of 500 Newton act for 10 seconds on a car of mass 1000. This caused the velocity of a car to be doubled. What is the final velocity? Here we have to use two formulas. First, we want to find the acceleration by using a formula that resultant force equals ma. The resultant force is 500. The mass of an object is 1000 and acceleration is 8. 1000 is multiplied, other side will be divided. So it will be 500 divided by 1000, which is equals to 0.5 meter per second square. So acceleration is 0.5 meter per second square. But we don't need acceleration, we need the final speed. So after 10 seconds. So example, when the car was moving, its speed is x initially. And they mentioned this caused the velocity to be doubled, so the final speed is 2x. Like if it was x originally, then it changes to 2x. And how much time it took? It took 10 seconds. So the formula for acceleration, which is a change in the velocity, final velocity minus initial divided by time. Acceleration we already calculated, which is 0.5. The final velocity is 2x. The initial velocity is x. And the time interval is 10. 10 is divided, other side will be multiplied. So it will be 5 because 0.5 into 10, that's equal to 5. And 2x minus x, that is equals to x. So x is equals to 5 meter per second. So option A will be the right answer. Is it clear, this one? Anyone having a doubt in multiple choice question 3?
No, sir.
Then the next question, which is related to motion. A ball rolls down a ramp and onto a horizontal surface. So what actually happened, like example, there's a ramp and the ball is rolling down the ramp. So there's a ball which is rolling. So when it is rolling, when it is moving down, it is accelerating because the speed is increasing. When it move on the horizontal surface, it does not change the speed. And the second section of a horizontal surface is a rough. So even horizontal section is divided into two parts. One is a smooth part, another one is a rough part. So when it move on the rough surface, it slow down. So it's like it will accelerate when it is coming down, then it will move at a constant speed and then it slow down. So what it shows, this shows that it was moving on the slope. This shows it is moving on the horizontal part, which is smooth. And this shows it is moving on the horizontal path, which is rough. So three different stages are there for this motion. First accelerating, then constant speed, and then deceleration or it slow down. State the time when the ball reaches a start of a rough section. So how we identify that it reaches a rough section? When it reaches a rough section, what will happen? The speed will start to decrease. So at this point, the speed start to decrease. So we'll find a time. At this moment, we draw a line. And as you can see, like 10 boxes equals to, this is 0.5. So 1, 2, 3, 4, 5, 6, 7, 8. So this will be 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. This is 10. So 10 boxes equals to 0.5. So each box is 0.05. So this will be 2.05. This will be 2.1, 2.15, and this will be 2.2. So at what time, what is the time interval when it enters the rough part or a rough section? That is equals to 2.2 seconds. So you have to write here 2.2. Explain how the figure 1.1 shows that there is no resultant force on the ball when it rolls along a smooth section. Look, when there is no resultant force, there is no change in speed or there is no acceleration or speed is constant. So when you check this part, the speed is changing. This part speed is changing. So there is a resultant force because the speed is changing. This part also the speed is changing. So means there is a resultant force. But the horizontal section, there is no change in speed. So what we can say the resultant force will be 0. Because for object to change the speed, we need a resultant force. So it is a horizontal line shows that the speed is not changing or no acceleration. That's why the resultant force is 0. So the question is how this shows that there is no resultant force acting. And it's of 2 marks. So 1 mark is for mentioning that it is a horizontal line. Shows no change in speed or acceleration is 0. And when the acceleration is 0, the resultant force will also be 0. Use the figure 1.1, determine the acceleration of a ball as it rolled down the ramp. So when it rolled down the ramp, the speed of the ball will increase. So which part it is rolling down the ramp? So only this part it is rolling down the ramp because the speed is increasing. So if you want to work out the acceleration, it's a straight line. We can, whenever it's a straight line for a speed time graph, then you have two options. Either you can use a formula, which is final speed minus initial divided by time interval, or you can use the gradient, which is y2 minus y1 over x2 minus x1. Both will give the same answer. We can take any 2 points, find x1, y1, x2, y2, and we get the gradient. That will be same as acceleration. And we can also use a formula. For a straight line, we have two options. So if I use a formula, the starting speed is 0. Speed at this point, so 10 boxes equals to 2. So each box is 0.2. So this will be 12.2, 12.4, 12.6, 12.8. So the final speed is 12.8. And what is the time interval? How much time it took to change the speed? So it is between 1.1 and 2. So it is actually 1.5. So we use a formula here. The final speed is 12.8. Initial speed is 0 and divided by 1.5. So expression is 12.8 divided by 1.5, which is equals to 8.5 meter per second. Is it clear this part, how we worked out the acceleration? So if it's a straight line graph, it's up to you. You can use a formula or a gradient. Then in part D, the ball start from rest at the top of a ramp. Show that the length of a ramp is 9.6. So length of a ramp is 9.6. Only we have to calculate the distance travel on the ramp and distance, because the ball rolled down the ramp, then the horizontal part, and in this horizontal part, first it is smooth and then rough. So what we will do, we will only calculate the distance travel on the ramp, and the distance travel on the ramp will be equal to the length of the ramp. And how to work out the length of the ramp? Because this part, it was moving on the ramp, so we find area under the graph. And area under the graph will give us the distance travel, and the distance travel is equals to length of this ramp. So we use the formula half base into height. So it will be half, the base is 1.5 and the height is 12.8, which is approximately equal to 9.56 or 9.6 meter. So whenever you need a distance travel from a speed time graph, always find the area. Why we did not calculate the area of the whole figure? Why only for the accelerating part? Because they asked only for the length of the ramp. They did not ask the length of the horizontal section. But what if, for example, the same question was there and they asked what is the length of the horizontal smooth section? Then what we will do, we'll find the area of this part. Because when it is a smooth section, it is not changing the speed. So area of this part is the length of the smooth section. And if they, for example, they ask calculate the area of the rough patch. So how we find? We will find the area of this part. But only they ask for length of the ramp. So length of the ramp is only this one. So this was the pop quiz, which was related to the moment, vectors, and motion.